Hi everyone. In the minimum size subarray sum, we are going to given an array of positive integers num and a positive integer target. Return the minimum length of this subarray whose sum is greater than or equal to target. In case there is no such subarrays, we are going to return 0 instead. Now, let us there could be two ways of solving this problem. Let us take our array, which would be value of 2, 3, 1, 2, 4, and 3. And our target would be 7. The first way would be we are going to have a window. So initially the window size is going to be 1. So we are going to have those values 2, 3, 1, 2, 4, 3. Out of which, right, none of the values is greater than or equal to target. Now we are going to increase our window size. So 2 and 3 would be 5. Then 3, 1 would be 4. Then 1, 2 would be 3. Then 2, 4 would be 6. And 4, 3 would be 7. This 4, 3 would be greater or equal to our target value. So we're going to return the window size of 2 out here. But there could be a situation in the OS time complexity if let's say the value could be, let's say, 15 or some bigger number, for example. In that case, right, we will have to go till the last element. So we have to increase our window size to 5. In this case it would be 6, sorry, window size would be 6. So if I do the time complexity of it, the time complexity would become big O of n square, which is not efficient because we are looping through this list twice. A question might arise, how can we solve it in a big O of n complexity? So there would be, you have to take two pointers. Let us take the pointers of left, which is going to be 0, and right, which is going to be 0. And now let us take our value, which is 2, 3, 1, 2, 4, and 3. Our sixth value target is again 7, and we're going to have a value called sum x, which is initially going to be 0. So initially we would be taking these two value and add to sum x. So let us take the sum x here, would be 0 plus 2, which is 2. So 2 is not greater than our 7. So in that case, we are going to remove or increment our right pointer by 1. We are going to take 3. So 2 plus 3 is 5, but 5 is not greater than 7. So in that case, we are going to increment our right pointer by another step. So it would be 5 plus 1, which is 6, but 6 is now not yet greater than or equal to 7. So we are going to increment our right pointer by another step and come to 2. So it would be 6 plus 2, it is greater than 7. So 8 is greater than 7. So in that case, right, once you have reached that, right, now our total length is 4. Okay. So we can have the minimum length, which is currently 4. Okay. Now it is greater than equal to 7. So we can do one thing. We can remove certain elements from the left side. So let us remove the 2 and increment our right pointer by 1. So our current value would become 8 minus 2, which is 6. So sum x value is 6. 6 is again smaller than the target value. So we are going to increment our right pointer by 1, which would make it 4. So 6 plus 4 would become 10. 10 is obviously greater than our right pointer. So what we can do, we can remove certain elements again. So we can increment our left by 1. So 10 minus 3 would be 7. So 7 is greater than equal to 7. So what we can do, we can remove one more element out from here and make this value to 3. And meanwhile, right, when you're getting this value, right, we are keeping on decrementing. Let's say the minimum length, right, we are going to keep on decreasing it, right? It will become 3 because you got a value which would make 7. So in this case, right, we are getting that value. So like 1, 2, 4, right, would make 7. So we would be decrementing that value. Now, once we remove the value 7 out here, right? So let us decrement 7 minus 1 would be 6. So once we get the 6 right, 6 is again smaller than our target value. So what we can do, we can increment our right pointer, and 6 plus 3 would be 9. So 9 is greater than 7. So what we can do, we can remove our left hand values from here. So idea is that if our values, that the sum of the values, right, is smaller than the target value, then we would be keep on adding the elements on the right. In case the value is equal to or greater than that, then we're going to remove the elements on the left hand side. So from there we're going to get the minimum size subarray. So in that case, right, we are removing the 2 value and making it 4. So it would be 9 minus 2, which is greater than 7, and the value would be 7. Now once the value is 7, right, and there, right, the 7 value is formed by just 2 elements, so we have to, the minimum length, right, has become 2 right now. Now what we can do, we can again remove 4 value, make it make it 5 for that matter. And once we reach 5, right, so it would be 7 minus 4, which would make it 3. 3 is obviously not greater than 7. And after that, right, we cannot move it because we do not have any more elements on the right hand side. So our loop will stop. So in this way, right, we can easily solve this problem. And here, right, our maximum time complexity, right, would be big O of n. So here, right, because you're looping through this entire list only one time, so it would be very, very efficient solution on our side. So we can easily solve this problem using the 2 pointers method to solve it. Now let us jump to the Python solution. Now for the solution, let us create 2 variables. So the first would be our j pointer, which would be 0. Next would be the minimum length of the subarray. Initially, we're going to assign it with math.infinity. So right now our maximum length is infinity. So import math. Once that is done, right, we can create another variable called sumx, which are from where we are going to store the our sum of the arrays. And now for the other pointer, let us do it through the loop. So for I in range 0 to length of our nums, and we are going to add that value sumx plus equal to nums of I. In case the sum value is becoming greater than or equal to target, so while sumx is greater than equal to our target value, in that case what we're going to do, we are going to remove the elements. So min length would be minimum of min length I minus j plus 1. So you're taking the current value and the previous minimum length, and out of which you're finding the minimum. It's an Python way of doing it. Then our sumx, we are subtracting the left hand side element, right, from the current sum value. So it would be nums of j, and then we are going to increment num or j pointer by 1. Pretty simple. Now what we can do, so once that is done, right, our solution is almost ready. Just we have to take into one more consideration. So what if the min length is still yet the math.infinity, means there are no probable solution that is available which is going to give the target value. In that case, we are going to return 0, else return our minimum length. Let me run the solution. There is, yeah. Let me run it now. It is failing. Let me check the issue. I minus j plus 1, which is fine. Again, a small spelling mistake. So spelling mistakes are very important for us to take care of. And now our solution passed. Let me submit it. It would be a pretty efficient solution because the time complexity is just big O of n. And once we submit it, it is beating 55.2%, and the memory is also pretty efficient because we are not having any additional memory except from two variables that we have. And if we run it again, our time is 93.08. So it is pretty efficient from the seeing of it. So that's all for this video. See you in the next one.